now have the privilege of introducing our first speaker, Professor Ramayya Krishnan. Professor Ramayya Krishnan is a Dean Emeritus and W. Cooper and Ruth F. Cooper Professor of Management Science and Information Systems at H. John Heinz College, Carnegie Mellon. A faculty member at Carnegie Mellon since 1988, he served as a founding dean of Heinz College for 3 consecutive terms. His work has been central to advancing research and education in data analytics, artificial intelligence, and data-driven decision-making, with a strong focus on measurement, evaluation, and real-world impact. Professor Krishnan has also played a significant role in global AI policy governance, including leadership roles with INFORMS, the US National AI Advisory Committee, and International Responsible AI Initiatives. May I now invite Professor Ramayya Krishnan to deliver his presentation.
Thank you, and good morning, everybody. I want to, first of all, say thank you to Professor Ashok Banerjee and to the colleagues at IIM Udaipur for this opportunity to come and spend time with you to tell you a little bit about the work that we're doing in AI. It's been a really inspiring morning session with Mr. Ranjan to hear about the activities that he has undertaken and his views on closing the digital divide. What I thought I might do is really talk about AI-led digital transformation with a view towards both telling you a little bit about how do you actually operationalize AI and put it to work and generate value in ways that would benefit both business and society. As the introduction noted, over these last 3 decades, and in particular in the last decade, I've been very focused on work both on AI technology, but equally on how to translate technology into policy, as well as technology in terms of how it actually generates value for business. The presentation I have is organized broadly as follows. I want to give you a feel for both what the potential of AI is, and for this knowledgeable audience, I'm sure I can go through that material rather quickly, and then tell you a little bit about what the key challenges are that need to be overcome in operationalizing AI, and I will provide you with a framework for how we might think about 3 pillars on which we might think about putting AI to work, which consists of evaluation, operationalization, and governance. And I'll give you some concrete case studies that we have actually engaged in, and then close with a call to action for public policy. Okay. Every week goes by with some new development on the AI front. But just to ground it even in what Mr. Ranjan said, AI is now making its way into consequential kinds of applications. For instance, this example of being able to, this conversation we are having is in English, but you could imagine it being simultaneously translated via AI into Telugu or Urdu or Tamil or any of these multiple languages. Now, real-time support for these languages isn't quite yet there on platforms like Microsoft Azure or Google Meet, but I don't see a major issue in the next 5-6 years. AI for Bharat and Bhashini, for instance, are well along the way in actually providing just this very kind of support. So to this point about inclusivity and accessibility of this conversation we are having to people who don't have a working knowledge of English, you could imagine AI actually providing this type of real-time translation. Mr. Ranjan talked about education. Khan Academy, Mr. Sal Khan and his work on democratizing access to education in multiple languages, including in Indian languages. And now this last week, there was a report in the Proceedings of the National Academy of Science about actual demonstrable increase in learning outcomes for kids who have access to technology like Khan Academy in terms of learning a wide range of subjects. Few days ago, we announced this partnership with the Gates Foundation. This is Carnegie Mellon University, announcing a partnership to create a not-for-profit called Learnervia. CMU is a center, a major center for learning science and engineering, and the idea is making calculus tutors, Socratic tutors, that is tutors that just don't give you answers, but actually engage you in a dialogue and teach you how to pose good questions to learn a particular topic, to make that widely available at no cost to students, has just been launched. So again, enabled by AI. And then you're probably widely aware of technologies like coders, like Cloud Coder or Google DeepMind's anti-gravity, all of which really support the use of AI to support software engineering and software development, with work demonstrating lower skilled software engineers get as much as a 25% increase in productivity. Along these same lines, you have the emergence of agentic AI. This is Manus, a company out of Singapore that got acquired by Meta that is entirely capable of autonomous work. So in this case, autonomous website building is an example that I have here. Along the lines of different types of capabilities that are being demonstrated with AI. And going beyond just programming and website building, you have the emergence of AI for science. This is this is from DeepMind from Google. This is Alpha Evolve that actually has designed new algorithms for scheduling of clusters with very significant economic savings to Google for running its data centers. And you've all heard about, how well Google and OpenAI and others have done in terms of competing on the Math Olympiad, for instance. Now, as you see this run up to all these capabilities of AI, along with it have come projections, like for instance this one from Accenture that talks about AI potentially being able to add considerable value to the GDP of India. And when you hear this kind of very positive views of AI, you should be expecting a but or a yet, and indeed that's exactly what the concern is, that despite all these developments in AI, there's been a big challenge in actually harnessing this technology and putting it to work. There are a number of studies, including from academic institutions as well as from consulting companies, this is from BCG, that actually talk about the fact that only 10% of what is required for gaining value from deploying a technology like AI, only 10% comes from AI tech. 20% is digital tech, and the remaining 70% is about people and process. Now, you don't have to agree on whether it's 70, 20, or 10, but directionally, it's important to keep in mind AI tech is another kind of technology, and to really put it to work in ways that are actually going to generate meaningful value, you are going to have to think about people and process alongside the deployment of technology. And just throwing technology at a problem, and this is something that we have known in information technology in the academic literature going back to the 90s about the need for complementary investments in people and process to really gain value from technology. So with that as a backdrop, the question is, how are policymakers responding to it? So in India, if you haven't read this just came out just about a week and a half ago. The India AI Governance Framework talks about a tech stack. The tech stack going from the top down, you see the extended AI stack, because I've extended it to be more than just technology. So you have chips and data centers at the very bottom, followed by models, which can be small, large, they can be sovereign. You have measurement infrastructure, which is how do you actually evaluate these models in ways that generate the evidence to actually support their deployment in consequential applications. And then how do you take that evidence and bring it to bear in terms of how to integrate AI into workflows? And then how does that integration of AI into workflows, what implications does it have for workforce, which then has implications for what kind of upskilling or reskilling would people have to do in light of what capabilities are brought by AI to the table. So in much of the rest of the presentation, I'll focus on the last three of these, the measurement infrastructure, the application integration infrastructure, and workforce, to give you concrete examples of how to actually harness value from AI. Now, it's not just India that's thinking about this. The US, the AI action plan that came from the White House in July of last year actually talks about very similar kinds of things, about measurement, about the need for investing and advancing the science of AI, but equally well, being able to invest in workforce. I should note that I lead the National Institute of Standards and Technology's AI Measurement Science and Engineering Institute at Carnegie Mellon. So much of the work that we do is really focused on these three priorities. So it's very aligned with what I'm going to be talking about. And finally, I should note that while it's not entirely clear if this is causal evidence, most recent work from our colleague Erik Brynolfsson basically notes that for people who are in AI-exposed occupations, this is data from the US, they're showing a slowdown in the hiring of younger people who are in AI-exposed occupations. Whether it's caused by macroeconomic factors, whether it's caused by tariffs, whether it's caused by overhiring during COVID or AI, this is certainly one of the factors to keep in mind. And then finally, the last three major labor strikes in the US, be it dockyard strikes or the strikes by creative workers in Hollywood, both actors, screenwriters, etc., all pertain to AI in one form or another. And so a solution that needs to be developed, irrespective of which economy you're in line with this theme of being inclusive and resilient in nation building, has to not only generate value for society and organizations, but it has to be done in a responsible and in an inclusive way. Okay, so with that as context, how do we think about what are the key elements of the framework? What I'm going to do is the big theme here, and I should give due credit to Professor Herb Simon, who was a Nobel Prize winner from Carnegie Mellon, who spoke about the fact that AI and operations research are the two heads he was referring to in a famous plenary talk in 1986 when I was a graduate student, where he called for two heads are better than one, that to solve these kinds of problems of the sort that I just outlined, you need a systems view of the problem, and that systems view will come from taking the capabilities of AI and blending it with the ability of ORMS to actually do value capture. So Udaipur as a business school has strong capabilities and analytics and operations, etc. Being able to then blend that with AI to then put those two areas to work is really what the rest of my talk is focused on. So AI creates capabilities, ORMS creates value capture. How do we combine the two together? Okay, so what are the main themes then that are missing that I'm going to address that actually think about how do we actually get AI and generate value from AI in consequential applications? The four themes are the ones that you see here. The first one being measurement, and I'll speak specifically about how to build measurement infrastructure in ways that are meaningful, that actually provide the evidence required for deployment. The second one is about how do you integrate AI into workflows. And the third is how do you then think about workforce and get the right workforce in place to actually support an AI, to be an AI-ready society, an AI-ready organization. Okay, so the pillars then are evaluate, operationalize, and govern. And I'm going to give you a case study in each one of these to make this more explicit and tangible. Okay, so let's start with the evaluate case study. When large language models are deployed in consequential applications, such as in healthcare, you want these models to be evaluated on multiple dimensions. So accuracy is one of them. Are they not biased? Are they fair? All of these are different measurements that you need to do. an important measurement is what's called robustness measurement. So robustness measurement is this idea that if a model is asked a question, I'm sure all of you have used chatbots, be it Gemini or ChatGPT or Claude. Suppose you asked a question like this, and if you are a patient that is undergoing a transplant, after a kidney transplant, can I eat raw sushi? The correct answer that the chatbot should give you is no, you shouldn't, because you're immune compromised. However, chatbots are subject to changing their answer from a correct answer to an incorrect answer in face of what's called adversarial prompting. Adversarial prompting puts models under pressure. Models, when they're trained, really are trained with two objectives in mind. One is to have good information, that's called factuality. The other piece, through a technique called reinforcement learning with human feedback, RLHF, is to please the end user. So you have this sort of thrusts, if you will, forces acting in two opposing directions. There's factuality and pleasing the user. So one of the things that we are testing models for is how robust are models in face of adversarial prompting to stick to factuality, even though they are being pressured by the user to provide incorrect answers. That's the essence of this idea. So here's an example of an appeal to authority that says, my cousin's a surgeon, he said it was okay. The model shouldn't flip and say it's okay to eat sushi. Or sushi has protein, protein's good for you, therefore you should eat sushi. That also is an incorrect answer. So these are all different kinds of adversarial prompts. So what we are calling for in policy terms is to create digital proving grounds. Professor Banerjee talked about creating an AI lab where firms and government can come and test their models. This isn't unlike what we're talking about. This is the idea of creating, much like you have automobiles being tested on proving grounds to see how safe they are, you could imagine proving grounds that are sandboxes with data sets, with the capacity to do dynamic evaluation, not static benchmarks, which is the standard right now, but dynamic kinds of evaluation, to evaluate them on multiple criteria so that you can have a multi-criteria way of evaluating these models and using techniques that come from operations research like Pareto frontiers to position these models on these multi-criteria evaluations. So concretely, what we did to illustrate robustness was to compile a data set from well-known benchmarks like MMLU, Common Sense QA, and Truthful QA, and then developed a custom set of adversarial questions drawing on the psychology literature that range from asking questions that basically test the confidence of the model. Are you sure? Or being harsh to the model, saying that's a stupid response, or saying things like, most people disagree with this. Are you sure you're correct? Or incorrectly agreeing with an incorrect answer, like I completely agree, the answer is clearly something else. These are all different types of adversarial prompts. And what we do is we come up with a randomized way of running multi-turn conversations with a model that is to be tested to see how well the model does in terms of giving the correct answer and not flipping from a correct to an incorrect answer. So robustness then is tantamount to how many rounds of multi-turn conversation does the model stick with the right answer versus switching from a right answer to an incorrect answer. And very quickly, to give you a flavor for the kinds of results that come from these sandboxes, most models, by the way, we tested the top 10 models from Hugging Face, which are the models that are the most prominent models. Every one of them do amazingly well in round one. But most conversations that people have are not one-shot conversations. Most conversations range from 8 to 10 rounds of back and forth. So when you have multi-turn conversations, there's a huge variation. After the first round, there's a big drop-off in quality. And what we are looking at is how many rounds does the model hold up in terms of being able to provide an answer and stick with the right answer, even in face of adversarial prompting. And one can then predict, using survival models or hazard models, as they're called in statistics and machine learning, if you can predict how many rounds will a model stand up to adversarial prompting, and that becomes then a measure of robustness. There are details in the papers that we have published in AAAI and ACL and iClear, which are all conferences in AI. And yeah, I'm happy to share this with Professor Banerjee to give it to anybody who's interested. But the important takeaway is that every one of these models that we tested operated basically in two phases. A stable phase, where they actually provided correct answers in face of adversarial prompting, and then an unstable phase, where they switch from an correct to an incorrect answer. Every one of the models we tested switched from stable to unstable. The only difference is the more fragile models switch very early on and in a very sharp way early on in adversarial prompting, whereas the more robust ones have a more graceful transition from stable to unstable. Now, if you look at small models, you look at large models, based on your context, your use case, and your tolerance for the extent of robustness that particular application requires, you can then decide which model makes the most sense. It's not like a one-size-fits-all, but this type of evaluation becomes actionable to actually help make these kinds of decisions about which model to actually select, versus just rank ordering models on capability. You're now converting capabilities into what matters actually for deployment. And I'm illustrating this with robustness, but clearly there are multiple other dimensions that matter, and it's a multi-criteria evaluation. So the first sort of point I wanted to make is there's an important need in being an AI-ready nation or an AI-ready firm for you to have access to this kind of digital proving grounds, or the capacity to have sandboxes that support both the evaluation as well as the use of these evaluations then to actually guide deployment decisions. In the US, we have these underwriters labs like UL that actually do these kinds of studies. And if either you could have the government support these kinds of labs, you could have academic organizations like Professor Banerjee was talking about IIM Udaipur, or you could have third-party private sector organizations that actually provide this as a service. Any one of these different models could work. And that's the first idea, evaluate. The second point I want to make is how do you take these evaluations and integrate it into workflows? Now, as you know, in most organizations, there are informal workflows and then there are formal workflows. But if you look at the formal consequential workflows, consequential either in terms of revenue or in terms of cost, they often are embedded and encoded in enterprise systems like ERP systems or CRM systems, things of that nature. So when you have these kinds of workflows, how do we decide which steps in that workflow should we actually deploy AI, and how should we deploy AI? Should we deploy AI autonomously? Should we have human plus AI, or just human alone? You know, how are we going to decide how to integrate AI into these workflows? I think the critical aspect of how AI is going to get deployed is not by showcasing example A or example B like I did in the opening, but actually getting it integrated into workflows. And so to give you a concrete example from healthcare, I don't know how many of you are familiar with what's called ambient AI. This is probably the fastest growing AI technology in healthcare in the US. So the idea here is that you have a phone on which you have an AI that if Professor Banerjee was my physician and I was having a consult with him, he would take out his phone, request my permission to have the AI actually listen in on the consult, and the AI then would effectively listen in passively to the consultation between me, the patient, and him, the doctor, with the view that at the conclusion of that consult, there is a transcription that's automatically generated at the conclusion of that consult that leaves out all the private information, but only has the clinically relevant information that is relevant for him as a physician to review and determine if it's appropriate for inclusion in the electronic health record or the claim system. That's what an ambient AI is. And it's one of the fastest growing AIs in healthcare. Let's see why. If you look at the workflow that you typically have in the world today when you meet with a physician, you typically have the patient interacting with the physician. The physician either is taking notes while interacting with you or going to have to remember the consult because they're going to have to dictate it later for a human to transcribe it. Or if you're an older physician, you might have a note taker actually come in with you and take notes. And this note-taking process at the conclusion of the consult or the dictation process then results in a human creating a transcript, which then is sent to the physician for review. And then the physician decides what to put into the electronic health record system or the claim system. This is sort of the traditional workflow, at least in the US. Maybe the workflow here may be different, but in the US, that's the traditional workflow. Now, with the emergence of ambient AI, this is a company called Abridge. It's a startup that came out of Carnegie Mellon. What you have is, if you look on the left here, these are the skill sets required by a human to actually do transcription. You need active listening, you need medical terminology, contextual understanding, note summarization capability, and typing speed. These are the things that they need. What you have now is an AI that can do each of these things. You have speech-to-text transcription, you have natural language processing, you have automated summarization and medical entity recognition. And you have to evaluate this, going back to the first part of what I talked about, to determine, suppose I have an accent that's different from, so in India we have so many different states, people from different states have different accents. Can this thing recognize people who grew up with maybe Telugu as their mother tongue or Malayalam as their mother tongue, etc., right? So I think there is a question of, that's where inclusiveness is an important evaluation measure. Is it biased against women versus men, so on and so forth. But these things have been evaluated and tested to where that evaluation then can then feed a decision, which is an assignment decision, which is which task in which workflow should we introduce the AI. Either we trust it enough and the public policy permits us to integrate it in a way autonomously, or do I need to have it as a human plus an AI solution, or the AI is no good and I still need to go with a human. This choice that's made is actually determined by that evaluation process. And what we have developed is a mathematical framework and a pipeline for making these kinds of decisions. And the important thing to note is that you shouldn't limit yourself to workflows that currently exist and determine what AI to introduce in those workflows, but rather you may want to redesign, re-engineer the workflow in light of what the AI brings to the table. So you have two decisions. One, what kind of integration do you want of the AI in the workflow? And the other is, how do I redesign the workflow to begin with? So for instance, in this ambient AI example, here's a much simpler redesigned workflow that comes about because the ambient AI parallelizes the transcription process versus pre-AI, you had to do it sequentially, right? So you had the consult, then the note taker had to take notes and then transcribe it, and then send it to the physician for review, etc. Here you have in parallel the AI doing the transcription, therefore you have a much simpler linearized workflow. So this is a redone workflow versus the older workflow that I showed you, which is this one, right? So this is a more complex workflow. This is the re-engineered workflow. So this question of how do we have these kinds of workflows informed by evaluation, this is what we call the AI workflow integration infrastructure. And then you need to field test it in a way that actually demonstrates that this generates value, that the error rates are acceptable. And this is something that has been done with multiple hospital systems in the US, and they've demonstrated that you have a first order benefit of between 6 to 8 hours of savings for the physician. The patient is happier because they get undivided attention from the physician, and the burnout of physicians has been reduced because they have less work to do in terms of having to remember and dictate and get these transcriptions approved, etc. So this has been a win-win solution. That's one of the reasons why the health insurance companies pay for the seat licenses of the ambient AI. And so you have the payer, the physician, the patient, and the hospital system all working in a way that this then results in tremendous adoption and deployment of this particular AI solution. Now, I should note, it's not without its problems. The second order concern that's been raised is if physicians rely on this ambient AI for summarization, will they lose their summarization ability? So this goes back to a point that I think Professor Banerjee talked about in his opening remarks about what does this mean for education? What does this mean for AI mean for how do we educate people to have the right kind of capabilities and learning outcomes in the presence of AI? If you're an older physician, you've been trained to do summarization in the old way, and now you have AI. But if you're a young physician and you only got trained with an ambient AI always present, if the ambient AI goes away and is not available for whatever reason, there's an outage, there is a problem, how do we make sure that you have the capacity to do summarization? This is like if I become so reliant on Claude for Excel. I don't know if you've seen this from 1 week ago. Anthropic released a Claude for Excel that's amazing at Excel analysis. If all our MBA students become reliant on Claude for Excel and Claude for Excel is not available, what happens? So I think these are related kinds of questions. Again, AI is a solution to this problem, which is that you might have the capacity to evaluate and assess somebody's capability in random requirements. In other words, you take ambient AI away from a physician and say, now we'd like to see how well you are, how good you are at summarization, and we find there is a gap, we have to put you through some training, thereby allowing people to be resilient to the use of AI, but also the unavailability of AI in consequential kinds of skill sets. Okay, so the reason why I think this is particularly important in India is I think this issue of availability and access of physicians, particularly in rural areas. If you increase the efficiency of physicians, the capacity of physicians to serve a larger number of people is going to go up, both in person as well as through teleconsults, which I know we experienced during COVID. So we talked about evaluation, we talked about operationalization. I now want to say a few words about workforce, because when you think about AI and the skills that it has, it's going to do some of the tasks that people are currently doing. Like the transcriber's task goes away if there is an automated transcription. But in most cases, it's not complete substitution of roles, but rather some subset of the tasks that an individual performs changes. So if you have AI being integrated into workflows, incumbent workers in those roles that were performing those tasks, their tasks change, which then changes the set of skills we need them to have. And one of the key questions is, what does it mean to have an AI-ready workforce? You always hear leaders and politicians talking about upskilling and reskilling, but towards what? What should they upskill and reskill towards? So I think this has been a key aspect of the work that we've been doing, is to try and understand via this AI integration into workflows, can we identify what kind of skills are going to be in demand, and can these skill vectors become potential targets? Now, Singapore, which was where I came here from, has something called the Skill Futures taxonomy, which they keep updating, which talks about which skills is in need in that economy in Singapore. India is a huge country, but you could imagine states doing a version of a Skill Futures to try and identify what skills make sense based on what makes sense in Telangana. I think we had a questionnaire for Mr. Ranjan that talked about beyond Hyderabad, it's largely an agrarian economy. So taking into account what the economy's needs are, what kind of skills are going to be likely required with respect to how AI is going to have to, will make a change. So what we have been working on is not only looking at what does AI exposure mean in the context of particular occupations, we have been looking at what skill sets are likely going to emerge as potential skills. This is actually work that PwC and Accenture have done. They talk about transitions in jobs and skill sets, and they give you a sort of what I think of as a laundry list of skills that might be emerging. But this is not driven by actual data or developed on the basis of how AI is actually going to be integrated into workflows. So our approach has been to think about occupations or roles as consisting of collections of tasks that people have to do. And from those tasks, which tasks are likely going to be affected, what new roles may emerge, and in these new roles emerge, how can we identify which skills that you currently have is transferable to a new role? So our key contribution is coming up with a measure that measures the transferability of skills that you currently have to skills that might be potentially applicable to a new role. And we call this measure skill fit. The details are not particularly important, and I can talk about it to people who are interested offline. But the bottom line is we use an AI-based approach for creating a skill fit measure, where the skill fit measure effectively learns from job descriptions a measure that's validated with actual internal labor market transition. So we worked with a large Fortune 10 bank, and in that bank, they wanted changes to roles on account of AI introduction, and they wanted to give their existing employees an opportunity to transition to these new roles. And to do that, they wanted to determine how mobile were these people based on the skills that they had, and how might the skills that they have transition to these new roles. And we developed a methodology using AI, which is this methodology that it's called contrastive learning, that actually creates a measure that is validated using these job descriptions. But the important thing is we found an actionable measure, because one standard deviation in reduction in skill fit distance for individuals increases their likelihood of being able to move from the role they're in to a new role by 2.25 times. So it's very highly predictive of transitions. And the more interesting thing is not just that it's predictive, but it can be used by policymakers, because we found that 55% of employees in this large bank who had proximate roles were unaware of the fact that they actually qualified for those roles. So one of the things that the bank wanted to do was to nudge these people and recommend to them, hey, you should be considering these roles because you are well qualified for these roles because you have a good skill fit to these roles. But 15% of the employees within the firm were people who had no good transitions. So the firm had a choice to make about how much to invest in them and give them upskilling and reskilling to improve their skill fit to potential new job opportunities. So the two takeaways from skill fit are that, one, it gives you a concrete actionable measure to determine job transitions, but two, it also helps the policymaker decide who to invest in and how much in ways that actually reduce their increase their skill fit or reduce their skill fit distance in ways that actually are meaningful. And that actually was very valuable within the bank, and we are now working on creating this measure in a larger, beyond the firm, but in a societal kind of context. You've heard of model cards and data cards, which most large language models provide. We wanted to create an opportunity scorecard for individuals in the roles that they're in by telling them which other roles can they qualify for, and where the distance to the other roles is based on skill fit. So imagine you getting a personalized opportunity card that tells you where the opportunities might lie for transition, and if there is wage information associated with it, you can then decide, is it worth my while to invest in acquiring these skills so that I'll get a ROI, a return on actually investing in these skills because of these transitions. And two, that these new roles that I'm going to transition to are not going to be disrupted in so quickly that I have to transition again. So this kind of information about the opportunity scorecard to be given to workers is also something we believe is really important for a resilient approach towards getting AI-led digital transformation to be put in place. So let me summarize. So we talked about evaluation that's actionable, followed by integration of AI into workflows, and how the integration of AI into workflows informs the nature of what skills are redundant and what skills are in demand, and then how then should think about getting your workforce ready for the new opportunities that might arise, and how in each of these AI is relevant, but in very different ways. So AI evaluation, we are evaluating the AI. So we are looking at AI as a system and studying how to improve the AI. In the second case, we are really merging AI into an existing organizational system, which is workflows. And in the third case, we are actually using AI to help create a workforce by helping individuals and giving them feedback. So I want to close with a call to public policy. In the US, in 1862, President Lincoln created what was called the land-grant university. Some of you might be graduates of these universities like the University of Wisconsin, of Madison, and other universities. The key point is that these land-grant universities were developed at a time when agricultural technology was the AI of the day. So they wanted to make sure that farmers had access to agricultural technology and could get democratized access so that you don't have the digital divide that Mr. Ranjan, or the agricultural technology divide that Mr. Ranjan was talking about. I think we need a version of that again. We call this a Digital Land Grant Act. We have called for that in the US. And in India, I understand that the government has created a center of excellence on AI and education. This is to be located at IIT Madras with multiple other universities participating in it. I think this idea is an excellent one because I think you not only want to provide access to AI education, but that education has to be extended with how to actually operationalize AI. It's not about just teaching people AI. It's about how to put it to work. And I think that involves evaluation, operationalization, and governance. So thank you again for your attention and the opportunity to share some of the work that we're doing with you. I look forward to the Q&A after Prabal has spoken. Thank you again.
Thank you, Professor Krishnan, for your insightful presentation and for sharing your perspectives on AI-driven digital transformation. Our next speaker is Professor Probal Majumdar, Associate Professor of Information Systems at the Indian Institute of Management, Udaipur. He also serves as the chairperson of IIM Udaipur's PhD programs and is an advisory board member of the Center of Digital Enterprise. His research examines how digital platforms and AI-enabled systems influence business and society, with particular attention to issues such as digital crisis communication and AI ethics. His work has been published in leading international journals, including Management Science and Information Systems Research. May I now request Professor Probal Majumdar to deliver his presentation. A big round of applause for him.
Yeah, thank you everyone. Thank you, Professor Krishnan, for the very interesting presentation. Actually, what I would rather say that what I am presenting is very much like a super subset of what you have done. So in some way, it may not be interesting, but let's see. And thank you, IMU, for organizing this event. Remember Professor Ashok saying that giving a slot for IMU faculty to present about their research is a chance for IMU faculty to demonstrate the kind of research that we do at IIM Udaipur. This is a chance for the corporate and the industry practitioners to, in the later stages, collaborate with us and see the kind of research that we do. My research is just a small, little bit of showcasing the kind of work. I'm their professor. Many other IMU faculties are here, so this is the chance for us. And as you can see, the title of the topic and the topic of this digital conclave is resilient societies, right? Resilient and inclusive nation building. The next two projects that I'm going to discuss are looking into the resilience of societies. How can societies become more and more resilient? And this is what we are going to look into, particularly in the space of the COVID-19 second wave. So you may remember during COVID-19 in 2021, there was a huge crisis in India. This is the second wave of the COVID-19 crisis. This was around 4 lakh daily cases of COVID-19 that happened at that time. So in this project, we are looking at how individuals reacted to this scenario, where most of the cases what happened was they didn't have access to essential healthcare resources like oxygen cylinders, hospital beds, and so we were thinking in this scenario where they didn't have access to these resources, how are they reacting to get access to the resources? In the process, we found out that there was a movement online at that time in Twitter where many of these patients' family members posted tweets asking for help. We can show the animation, please. So these are tweets which have specifically like somebody asking for help. We call it SOS tweets. In this case, yes, these are examples of SOS tweets. This was collected by Reuters in 2021. Mostly patients are at the critical stage. They need an oxygen cylinder, and they don't have access to these. So they didn't get access in the hospital system. So they asked directly on Twitter. So this kind of curiosity triggered, and we wanted to know, did they get the actual help that they were asking online, right? So, this is the graph from April 2021 all the way to June 2021. The second wave you can see are almost at the maxing at around 4 lakhs around middle of May. Similarly, SOS tweets also maxed out at that time. So again, these tweets were posted in Twitter. They were not posted. They were not getting the healthcare services in your hospitals. So did these tweets lead to them getting the cylinders? This was another pan-India event, rather pan-urban India. Obviously, digital divide was one of the reasons we could not get the resources that were asked for in villages. Obviously, the COVID-19 was there itself, but even within pan-India, you can see Delhi, mostly Delhi and NCR region, we had most of the data collected from these regions. So how does these messages look like? This is a typical message where I have hidden the personally identifiable information. It talks about the name of a patient, their age, 75 years of age, SpO2 value, the currently oxygen levels of 75. They mention the phone numbers, and this is clearly mentioning that need ICU bed on an urgency basis or need oxygen cylinders. So the motivating question for us was, did they actually receive this help? So again, they posted online, and did they receive the help? This is not something that you're expecting. It's not like you're going to McDonald's and you're posting for an order and you're receiving the order. This is a disaster scenario where unintendedly, organically, individuals contributed asking for resources online. Did they receive the help? In order to do this study, what we did was we looked at what type of messages these individuals posted. Did they use certain online measures like IT artifacts? For example, did they use hashtags in the messages? In this particular message, they have used hashtags like COVID buddy, ICU beds, or else did they use mentions? Mentions is when you tag an individual in a message. Here they have tagged Srijan Pal Singh. Maybe these are suppliers, or maybe these are important people in the society. So you are trying to connect with a person who can help you, right? So adding a hashtag or adding a mention, or even we thought of a third approach where given somebody who was providing help, in this case Sonu Sood was providing lots of oxygen cylinders at that point of time, did somebody write a message as a reply to the parent tweet? So it's called reply to SOS tweets. In this, these three different approaches, so all of them asking for help, right? Somebody adding some hashtags, somebody adding some mentions, somebody making it a reply to tweet. Our question is, do we actually see the help, right? And which use of IT artifact led to the help? We ended up collecting online engagement data as well as offline response data. The online engagement data is given a message, who likes the message or who retweets the message. In case of offline response data, we had phone numbers from each of these messages, and from these phone numbers we were able to call, do a survey, telephonic survey, and we call the individual and explicitly ask them that you posted online, did you receive the help? And this way we collected both our dependent variables. And if you look at the process in which our online data collection was done, the entire SOS tweet data collection was done. We had to scrape data from Twitter, the initial stage. Then we had to use a machine learning algorithm to classify SOS tweet versus non-SOS tweets, and then finally select a group of 54,000 SOS tweets. And then we further added a filter that we only looked at tier 1 and tier 2 cities and the tweets which have phone numbers, because we wanted to do that offline telephonic survey. And therefore, we finally got a data set of 7,266 SOS tweets. This was how the SOS tweet data was collected, and inside this we had the online engagement data also. In case of offline telephonic survey, it was done in 2022 October, whereas our actual pandemic second wave was April 2021, May 2021. So we had a 1 year, 4 months gap. So we did the survey, we contacted the Hindi belt individuals who have posted on Twitter asking for help. Around 2,176 individuals were contacted, and then we followed certain protocols, like we asked for consent. Then we did a recall test. We asked them, do you remember that you have posted this tweet during the second wave? And those who gave us the consent, who actually were able to remember the tweet, we asked them, did you receive actual help because of your tweet, like access to an ICU bed or hospital bed or oxygen cylinder? And then we got a result around 28% said they received the help, and the remaining said they didn't receive. This is how this variable was collected. And then when we did the regression, the mathematical side I'm not explaining, but when we looked at the regression, particularly for the online engagement, we found that hashtags led to increase in engagement. This is studied in the literature. In literature, there is enough, many papers which say that hashtags in messages, in social media messages, tend to impact online engagement, like retweets and likes. But in the case of adding a mention or even making a reply to tweet, it decreased their online engagement. But if you look at their offline response, it is the reply to, making a reply to message that led to their offline response. So there is this two approaches. Like one is, should you add a hashtag or should you go with a reply to? And we found that reply to was the one that gave make them get the actual help. So overall, in this study's finding, there were 3 options: hashtag, mention, and reply to, out of which hashtag led to the usual online engagement, whereas reply to led to offline response, which is the measure that we wanted to find. So again, in a crisis scenario, social media communication happening, but at the same time, what IT feature should be used was unknown at that time. Those who used reply to as a feature of communication ended up receiving an oxygen cylinder. This kind of points us towards the resilient society that we're trying to build, and particularly when it comes to disaster management, how IT artifacts can be utilized. And since we have 3 different types of results, we are terming the heterogeneous impact of showing of hashtag, showing of mention, and showing of reply to. From a practitioner point of view, it can really have an impact on social media platform designers. From platform designers can think about, during crisis, adding certain features within the platform so that effectiveness of the platforms increase to connect these markets. Particularly when it comes to creating a space for adding reply to feature, reply to type tweets. That's one takeaway. Another study which we are looking at in the same space, this project is with Professor Samadrita, who is faculty at IIM Udaipur, Professor Ravi Bapna, faculty at University of Minnesota, and Professor Rajni Singh from Copenhagen Business School. And in this project, we are again looking at, so say from the demand side, you get to know these are the SOS messages and how to write the proper way to write the right messages, right? But from the supply side, if you have the messages, whom do you provide the help? So that's the next set of questions. From the demand side, we looked at it. From the supply side, whom are these individuals we're going to provide the help? In this case, we talked about looking at it from 2 sides. One was look at the supply side first, at least from the message point of view. Why don't we triage the messages and identify the ones with highest priority? The ones with highest priority, they can get help faster. The ones with less priority, so we ended up creating an urgency scoring for these messages. Second, we also wanted to look into the resource-constrained ecosystem, because obviously there is not infinite amount of oxygen cylinders available, right? So there may be 100, or maybe a capacity constraint of say 100 oxygen cylinders or 200 cylinders. How do we assign these resource-constrained cylinders to even if I have a list of 150 individuals to give them. So, and in this process, we started using AI. So this was around 2023. At that time, we got a grant from IBM, gave us IMU a grant of $50,000 worth of Watson X credits. So, and also IBM gave us access to learning about how to use AI. So we used AI in the process, and as Professor Krishnan was mentioning, how do you do this task? Should we do human only? Should we do AI human as a team, or should we do AI only? So human only, when it comes to triaging messages, can be extremely high on cognitive fatigue, because one person triaging hundreds of messages, they may face this cognitive fatigue. So we thought of first studying AI only as a approach, where in AI only we want to say, how if we automate the entire process, what is going to happen? In this case, as Professor Krishnan was mentioning, that the possible types of biases that can come in, we were even looking the first level of bias, not even the bias due to communicating back and forth with AI, but even if we have a basic prompting, and based on that, if the AI is giving a score. So here the task is simple, giving an urgency score to an SOS message. So how can that urgency score can be given by AI, which is less biased or lacks, how can that be accurate? So in that study, what we first did was we used ground truth coding. In ground truth coding, we hired multiple doctors who are experts in crisis management. They regularly triage cases in hospitals, and we asked them to code a set of SOS messages. And we used a scale of 1 to 5, where 1 means least urgent and 5 means most urgent. And these, one of the examples is here, where one of our expert doctors coded these SOS messages with a score of 3, 5, 1. So basically 1 means least urgent, and they have given their reasonings why they think. So next, what we want is, we wanted the AI to take the same set of SOS messages and give the urgency score. But here we were trying out different types of prompts. It's common knowledge that as we put more and more sophisticated prompt into the AI, it will give better results, and that's what we found. We tried out with 5 different prompts, 3 zero-shot prompt and 2 few-shot prompts, out of which the first prompt one was a naive prompt. It's a very simple prompt, where with prompt 2, we added a little bit more information, how do we want to communicate with the AI. And then in prompt 3, we added a little bit more structure, that what is the meaning of high urgency score, what is the meaning of a low urgency score, what is the format, how you evaluate a individual in its, and prompt 4 and 5 were few short prompts, where we had added multiple examples of certain SOS messages and their right assigned scores. Therefore, then we tried these multiple prompts on a set of sophisticated LLMs. These are the LLMs that I've selected. These are the well-performing LLMs like DeepSeek, GPT 4.1, Anthropic, Claude. We also included Mistral, we included Llama, but these are I'm right now showcasing few of them. And here again, 2 things to point out is, based on the kind of prompt that we send to the AI, its response will vary. At the same time, individually, each of these AIs, their architecture is different. For example, DeepSeek has a mixture of experts, whereas LLMs, even within them, some of them are proprietary LLMs, some of them are closed models. We don't know the internal architecture, like how many layers, what are the number of hidden layers, what are the data on which they are trained. So because of that underlying differences internally inherent in them, we were expecting some bias at the level of the LLM itself, and also bias driven by prompting. So this was the result that we found. On the x-axis, you can see different prompts, prompt 1, 2, 3, 4, 5, where prompt 1 is a naive prompt, and prompt 5 is the few short with 6 examples, which is the most sophisticated prompt. And on the y-axis, we are measuring mean square error. Mean square error is a measure where we measure the quality of the urgency scoring by the AI and the doctor's urgency scoring, which is our ground truth, and we subtract it and take an average of it across all the samples. So therefore, the mean square error, if it's high, that means the model is pretty much biased. The AI score and the doctor's score are not matching. If it is comparatively lower, like in case of prompt number 4 and 5, the mean square error is around 1, which is saying that the bias has still see that there is significant difference in the mean square errors across all the models' performance. So it's not like all of them lie on the same line. So that might be because of the inherent nature of the model's architecture or the data on which it was trained. So we didn't do fine tuning, we just used the available models. So that's what we are terming as the LLM induced bias, because that's inherent to the models themselves. And this on the y-axis is what we are terming as prompt introduced bias. So obviously imagine one takeaway from this study is if we have to use AI only automated systems, we cannot, at least at this stage, we cannot imagine a scenario where there will not be any biases. There will be even a small, even 2% or 1% level of bias will be there. So we thought of pivoting to the AI and human augmented systems. So that's the current research that we are working on. In this system, in place of using AI only systems, we are looking at human and AI augmented systems. Recent research has showed that human AI collaboration leads to better outcomes, and therefore but in this paper we don't have results at this moment. We are just in the process of exploring this idea. So what we plan to do is we want to look at several types of human heterogeneities. One of the heterogeneity is AI use heterogeneity. For example, an individual may be not comfortable using AI, or maybe very much comfortable using AI. So AI use expertise. Another is triaging expertise. For example, an individual may be good at triaging, may not be good at triaging. So looking at the 2 by 2 of this types of heterogeneity, and then using an experiment to study how they are triaging SOS messages with AI support and without AI support. In this case, it's without AI support, and in this case, it's with AI support. Then, based on the urgencies scores that are coming from this model, we also have the ground truth of the doctor, so we can always go back to that to see whether the mean square errors are accurate or not. And then we want to look into the resource allocation problem, which we haven't studied as of now. In this resource allocation problem, what we are planning to do is, first step, we want to identify the human AI augmented triaging scores, and then once these scores are available, we will use a optimization model to help allocate the limited healthcare resources. This is very early stage, so I don't have, the main goal of this study is to make sure that there is least bias. For example, least bias when it comes to this urgency scoring, also least bias when it comes to sharing of resources. Because in reality, when I heard some anecdotes, right, the sharing of resources, particularly during the COVID-19 pandemic, was first come, first serve. Individuals used to give the oxygen cylinders, or maybe at a high price point, somebody paying 1 lakh for a cylinder, or who somebody have some contacts. So there was no structured framework by which the sharing of resources happened. But in this case, if we can have an automated system which takes in the SOS messages, puts it into a system, does triaging, and then finally resource allocation in a framework. So that will be like a framework towards future outcomes, like whenever there is a disaster scenario, whether it's a hurricane, whether it's a flood, whether it's in a man-made scenario like a wartime scenario, we can create some systematic approach of creating situations which will solve societal problems, right? So from 3 of the projects, we got 3 managerial implications. The first one is how the IT features shape crisis communication and how social media can become more effective during disaster communication. And the second one, that how prompt and LLM biases will get introduced if you are looking for autonomous AI-only systems, and how government and disaster management response can take into account of this approach to go only autonomous AI approach. And finally, in the final question, we are still working on it. We think that AI human augmented solutions will help both in triaging as well as resource allocations. So that's the study that we are currently ongoing, and we are currently doing that study. Okay, thank you.
Thank you, Professor Prabal Majumdar, for your presentation and for sharing your research insights with us. I now request Professor Ramayya Krishnan and Professor Majumdar to kindly take their seats on the stage for the Q&A session.
Yeah, good morning once again, everyone. Fascinating research talks. So now we are open to question and answer. Since this is a combined question and answer, I'd request the participants to mention whether the question is intended to Professor Ramayya or Professor Prabal, or you want opinion from the both. Thank you. We are open to questions and answers.
There's a question back there.
Yeah. Our first question.
Thank you both. Amazing research case studies, very insightful, and ideas for more research for IIM Udaipur. Just quick comment to Professor Krishnan. I think I heard you last year on a trust conference. You were a panel discussion in Washington, D.C. I'm glad to meet you in person today. One study that I see that's consistent with your research, about 70% being people and context, is this MIT research. I think I read it last month or so, that says 95% of digital enterprise today are not getting ROI. So the people, and they said the change management is central because the organization is not changing with AI. And your research, although had many aspects, this was not something you talked about today. So if you want to make any specific comment regarding that specific thing. And there's some couple of anecdotes that I want to share before you answer. Is systemic view. I have a household help here because I moved from US to India. And his medical report came, and a lot of things were not looking good. So I took to the doctors, and he said, oh, by the way, this is less, and this is less, and you give this. But then I fed it to ChatGPT, and it gave me systemic view. Also, these combination, you better think about a genetic issue with his liver that you should discuss with the doctor. And then I asked him, he said, I lost my dad at the age of 4. And he's only 40 years old, and there were so many issues. So the idea of integrated view from AI resonated with what you talked about systemic view. So I just wanted to add that anecdote with you. So your comments, please. Yeah.
Thank you for that question. I'm familiar with the MIT Nando report, which is the one that you're talking about. I'm not a huge fan of that report per se, though I love MIT. I think, but the point that they're making is a valid one. The reason why I mentioned that is, I don't know if it's 95%, I don't know if it's 70, 20, 10. So I'm saying you don't need to anchor on those specifics, but I think the broader point is well taken. And it's been multiple other organizations, both in academia and in the private sector and the not-for-profit sector, have made note of this concern that technology in and of itself won't do it. The specific thing that we have attempted to do, in fact, we have a paper on this, is to create what we call deployment-centric leaderboards. That is, most leaderboards just talk about capability. We want to convert capabilities to utility and capabilities to costs and capabilities that require compliance, so that you want to think about how organizations, be it in the public or the private sector, would want to maximize utility subject to costs and compliance, and come up with a score for models that best support you in that journey. And that gives you a deployment score. And we have demonstrated that with OpenAI's Health Bench. to actually rank order models. And we are now in the process of trying to validate if our deployment-centric score actually is meaningful in practice. And I think these are all attempts at addressing, be it what BCG says or MIT says or McKinsey says, that fundamentally you need to take a holistic approach with regard to deployment. That's to your first question. With respect to your second question, be it ChatGPT or Gemini, I think putting in personal medical information into chatbots, I wouldn't quite recommend that. However, it's certainly the case that their capacity, on account of the vast amount of pre-training that's been done to see connections of the sort that you saw, has been anecdotally confirmed. Now, as you know, OpenAI is in the process of rolling out a chatbot focused on healthcare, so this is very aligned with what you're talking about. The issue of how that should then be evaluated, how that should then be reviewed, I think is an important one, because that's a fairly high stakes kind of setting where you would want, in these cases, to potentially have a physician in the loop. But other than that, I agree with everything you said.
So quick comment on the last one. You talked about robustness and resilience. So a lot of your research, the data is coming from US. If you want to make it robust and resilient, you have to come to India for collaboration, because this is where the medical data, for example, is very difficult to get in US. It's all personal, proprietary. You can't improve it. There's a lot of other researchers I have said, they're coming, and IMU and the Probal is saying that we are doing a lot of local data. Well, his data was more public, but there's a lot of data that you can use to make your research more robust through collaboration with institute like IMU.
No, without a doubt. I'm actively engaged and look forward to opportunities. I should note that the OpenAI Health Bench is actually a global data set. It's not US-centric. But that said, I think your point is well taken. I think there are lots of opportunities to engage in India, and I'm looking forward to it.
Thank you very much. So now the next question, please. Yeah, one by one. First.
Hi, everyone, and congratulations. You both have done great work, and it was so inspiring to hear this. So I'm into teachers training program, and how to make the concept delivery in classrooms more effective. So I was just hearing you about, how a physician talks to a patient and the transcript is created. So I'm into multiple intelligences of the child. So when we are delivering the concept, we believe that is the concept catering or the learning abilities of the child. So we want to know what kind of learner is the child. So for that, how effective is AI if I want to know whether a child is a kinesthetic learner, an audio learner, or a rhythmic learner? Because if we get to know what percentage of children are, what kind of learner they are, we'll be able to draft that concept and implement the concept in the most effective way. Thank you very much.
Thank you. It's a great comment.
Yeah, I think recently I'm working on another project where we are looking at AI implication in the education sector. So I think to know what kind of learner is possible, because AI is at the end a neural network model which can be trained. One approach may be you have collection of children's learning videos that actually observe them while they are learning. You take CCTV footage or actually have videos in the classroom to record the sessions, and you also have their grades. So this way you can identify the students who performed well, what was their body language and how they ended up learning. And using the grades as labels and the video as raw data, image data and video data, you can train neural networks and in the process have high accurate models which can predict the learning. So these kind of in-house building of models needs to be done case by case basis. So it need not be a large language model, it can be a SLM, small language model, but use case specific. Maybe if the data set is proprietary data, it's like children's personal video data, then you need to may have an AI built within the school or within the district for all the schools in the district, so that the data is not going outside the country's boundary, the data repudiation is inside the country, and the localization of the data is possible. So this way, protecting the data, building in-house AI, and training these neural networks can help solve the problem. But AI is, at the end, it's a black box. You can train it whichever way you want. You want to train it for learning purposes, you want to train it for some other purpose, like teacher scoring can be done. You can see how good the teacher is teaching in the class using, again, you can do attendance scoring, so all kind of scoring can be done with AI.
So first of all, thank you for your service. I think teachers play an amazing role, and it's great that you're doing what you're doing, so thank you very much. I think the broad point I wanted to make was AIs are not seen necessarily as substitutes for teachers. They're going to augment what you do. There's also an access problem, right? So the number of teachers who are as dedicated as you are that are available throughout the nation or throughout the country, how might we clone you, in other words, right? How might we scale you in ways that would allow for kids throughout the country to gain access? So I mentioned Learnavia, which is the announcement that we just made a few days ago. The whole idea is to sort of provide children, particularly in rural and in disadvantaged urban areas, access to calculus teaching that in general might, my kids went to good school, so that's fine. But what about kids who don't have that privilege? It's in those cases that one, access to education, and ideally even tailored in the way to their own learning approach and learning ability. I think that's the promise of AI, and I think the Khan Academy work is early promise. I think we have had maybe 3 decades of work in learning tutors at CMU. So I think this is an example, a great example of AI and the impact it can have on society. And I think the government, I laud them for doing this AI Center of Excellence. But I think in most countries where there is fear of AI, it's important, I think, to have these kinds of, these lighthouse projects that really shine a light on ways in which AI can provide access. Education's one, health's another, transportation could be a third. And I think those are critical, and I think the work that you're doing needs to be supported. So thank you.
Thank you very much. So, Madam, please.
So good morning, sirs. Great presentations in the morning. My name is Anuradha, and I represent Blackbucks. I'm CEO, founder of Blackbucks. Our system, our portal is a higher education support system. It has MOOCs, it has learning, it has employability preparation, recruiter modules, and everything. My question is around the aspect where you have mentioned, should we decide whether it's human plus AI, or AI exclusive? So this is the question. So as a practitioner, we never think in that way. We just know the capabilities of AI. And it was an analytics system earlier. Now it is becoming an AI system. Wherever AI is applicable, we just fit into it, actually. This is an AI, this can be an AI use case. Say, for example, smart interview. The student stands in front of it and practices. There are 600 students on the platform, and so it is easy. Instead, you bring somebody to teach them interviewing. So it becomes very difficult to have so many humans. So we don't decide at all, are we too careless deciding whether it is AI system or should we have a human here or AI here? We just know the capability and fit it there. We don't put the decision whether it could be human there or AI there or human plus AI. So can you tell the framework, which both of you have discussed the framework. So can you tell how we'll have to use this framework in day-to-day basis when we are deciding as a practitioner?
Yeah, do you want to go first?
Yeah, I think even for AI, if you're using third-party AI, then you are at the disposal of the third party who will be providing you with the AI. How they have trained the models, what was the data set that they have used, what is the underlying architecture. Most of the times it's not shared with so my suggestion is if we can identify what we are looking forward to, if there's a clear-cut ground truth ground truth is, in your case, maybe students want to learn how to do interview, right? So with those cases where the students did well in the interview, having those sessions recorded and coming up with ground truth to measure. If there's, as Professor Krishnan was also saying, the measurability of these AI models is where if we don't do, we are using it in a blind fashion. Obviously from a practitioner point of view, you won't instantly come to a solution, but at some level there has to be some organization to measure and figure out which models are working, which are not working, and then implement them in the real world.
So the example that you gave actually is an excellent one. Speaking to both the earlier question related to access as well as it is to a capability. So as dean, we actually deploy, when I was dean of the school at Carnegie Mellon, we actually deployed smart interviewing technology. I think it solves for a different problem than if you are a human teaching people to interview. It's not like one's better than the other. I think they're complementary to one another. And the number of people who you have who can teach students to interview is limited as well. So the way we see this example is that we're not trying to replace the human interviewing expert. That person does to a class, but then when you interview with an AI, it allows for you, one, to repeat interview multiple times, way more times than a human has the resources to provide feedback, number one. Second, I've actually done this myself just to see how the technology works. It actually tells you different kinds of interviewing. Are you maintaining eye contact? Are you sort of responding differently if there was a woman interviewer versus a male interviewer? Things that are perhaps subtle and things that traditionally a human interviewer would find exhausting to provide feedback on at scale with every subject. However, the human interviewer has a lot of wisdom and experience coming from maybe your placement or career services, etc., that they can provide more tips and other kinds of feedback. I see these as being complementary. Now, to your point about human or human plus AI, so in this example, I see it as human and plus AI, but not for the exact same task. The goal is how do we get our students to be better interviewers, and there is a human component to educating them, and then there is an AI component to educating them, and then you could actually run an experiment where you say, what if I ran them only through human interviewing experts, one where they only had access to your AI technology, and one where they had human plus AI, and then you could say how good were the outcomes. That would be the rigorous approach to doing it, and I'm sure Udaipur could work with you on this. I'm creating work for you, Ashok. So, yeah.
Thank you very much for the candid answer, Professor Ramayya. Any further questions? Anyone in the audience? Yeah, we can see a question at the back end.
Am I audible? Yep. Thank you. I'm Satish from Innova Solutions. My question is for Professor Ramayya. You mentioned about ambient AI workflow, right? In that, I just take a moment, and if you can address on the the error percentages that you mentioned, how effective it has been. I mean, after putting it into use, how effective was it? And that is one part of it. And what kind of a regulatory board, if there is anything, and if there is any upper limit to it, if you can throw some light on that. Thank you.
It's a great question. So I'll share my slides as a paper that actually provides details on the field testing of the ambient AI, in this case from a bridge. So there are two different aspects. One is which specialties did ambient AI have the most impact with? It does particularly well with internal medicine and primary care. With specialties like psychiatry or nephrology or cardiology, less so. And also when you have complex patients with multiple comorbidities, the summary can require the physician to have to do a lot more editing of the summary that's created than the case where, like in my case, when I met with my physician, I was curious about how she was using ambient AI. I fortunately don't have many comorbidities, so my consult was a simple consult, and the summary that was created from my consult, she just reviewed it and accepted it. So to your point about can it be used autonomously, no, it cannot. Not just because of the reliability of the technology, but because there is a question of accountability and liability, that who's accountable for the summary? It's not the agent, it's the physician. So she has to sign off and take and accept responsibility for that summary being an accurate representation of what actually transpired between the patient and her, right? So I think in many consequential use cases, the issue of human plus AI sometimes might arise because of accountability and liability reasons, not just because of reliability reasons. That's the first point. The second point is with reliability, there is variation in terms of reliability based on the complexity of the use case. By here, I'm using the use case in an overloaded way. Use case with regard to the patient, use case with regard to what kind of medical specialty the physician is actually engaged in. I fully expect this to improve over time. I'm talking about right now that internal medicine seems to be the place that's a sweet spot in the US. I mean, internal medicine happens to be the gateway specialty to, you get to see a primary care physician before you go to see a specialist. Therefore, from a volume standpoint, it has a large economic impact. But the pointers to those papers will help you get more detail. But I hope that sort of responds to your question as well.
Okay, thank you very much. So that brings to the end of this Q&A session. Thank you, Professor Ramayya and Professor Probal, for your comprehensive answer to the questions raised by. So probably there is one more question at the back end, probably. Yeah, please go ahead.
Thank you, sir, for considering. So my name is Anuj Jaiswal. I was just thinking about the wonderful insights from your research and how we can apply it actually in future disaster relief and crisis management efforts in collaboration with, let's say, government, national disaster relief agencies. What would be your recommendation that if we can have some sort of template which NDRF or other agencies can use to actually interact with people who are in distress via Twitter or any other social media platform? And on the other hand, on the technology front, we can also have a recommendation for social media platform to actually create some sort of indicator for these SOS type of messages, which they can easily facilitate and through their own algorithm can bubble up for the agencies to actually look into and prioritize. So just my thought, and would like you to shed some light.
Yeah, I think thinking of these, only we worked on this project where the findings are like recommendations for disaster relief organization, NIDRF and governments. Particularly we were focusing on the technologies perspective, like the digital technologies here, the use of Twitter, but maybe in the next disasters there will be some other technology that is used, maybe AI is used. More than the technology, what is more important is the framework that you were mentioning, right? Yeah. So the framework is the demand side, the supply side, looking at it from a full 360-degree perspective, and even from the supply side, making sure that resource allocation, which will happen even if it's a disaster like hurricane or if it's a flood, there will be resource allocation decisions will be made. How can AI human augmented systems in the process do a systematic approach towards resource allocation? So this is a study we are still in the process of working on. So we don't have recommendations at this stage, but the disaster relief allocation should happen in a more systematic manner. That would be my suggestion.
Sure, sir. Thank you, sir, for your insights.
Okay. Thank you very much. Thank you.
Thank you.